Let's review a little bit and multiply A times B and B times A. So if we multiply A times B, we have a 2 by 2 and a 2 by 2. That means we can multiply them and our answer is going to be a 2 by 2. Remember, when you multiply each row by each column, like that. So we're going to have negative 3 times 1 plus 0 times 0. Negative 3 times 0 plus 0 times 1. 4 times 1, 6 times 0. 4 times 0, 6 times 1. Negative 3 plus 0, 0 plus 0, 4 plus 0, and 0 plus 6. Okay, let's multiply B times A. So 1 times negative 3, 0 times 4. 1 times 0, 0 times 6. 0 times negative 3, 1 times 4. 0 times 0, and 1 times 6. Negative 3 plus 0, 0 plus 0, 0 plus 4, and 0 plus 6. Notice how these are the same. Also notice how these answers are the same as that one. That's because we multiplied our matrix by these ones and zeros in a very specific order. This is called the identity matrix. If you have ones on the diagonal from upper left to lower right with zeros everywhere else, that's called the identity matrix. And an identity matrix is just like if you had, I'm sure at some point in your life you've heard the words multiplicative identity. So if you have 4 times something equals 4, that number is 1, right? Anything you multiply by 1, you just get that anything back again. Anything times 1 is whatever that you multiplied by that 1. Well, this is called the multiplicative identity. That's the same thing with this one. This is your multiplicative identity. So whenever you're talking about the identity matrix, it's always ones on the diagonal, zeros everywhere else. And it does need to be a square matrix. It is a square matrix. So you could have a 4 by 4, or 10 by 10, 100 by 100. As long as you have ones on this diagonal and ones everywhere else, that is called the identity matrix. So if you were to multiply a matrix by another matrix and you get the identity matrix as your answer, then those two matrices that you multiply. So let's just see how that works. Here we have matrices A and B, and I did have a little correction here. This is a 2 and this is a 1. I'm not sure if I corrected your note, so just make sure. We want to prove that AB is equal to the identity and BA is equal to the identity. If we can do that, then we have proven that A and B are inverse matrices. So let's multiply A times B. So that'll be negative 9 plus 10. This will be negative 5 plus 5. This will be 18 minus 18. And this will be 10 minus 9. Hopefully you're getting better and better at multiplying matrices, and you can just go through them really fast like that. So negative 9 plus 10, negative 5 plus 5, 18 minus 18, and 10 minus 9. So far, they look like they are inverse matrices. but we do have to multiply them in the other direction just to make sure. So let's do B times A. So we're going to get negative 9 plus 10, negative 45 plus 45, 2 minus 2, and 10 minus 9. That's 1, 0, 0, 1. So we have shown that A and B are inverse matrices. And you can write a little proof out with that. You can say, since AB is the identity and BA is equal to the identity, A and B are inverses.